Hello, compressed air friends. So today is the big day. We're going to be installing this Airmatics smart tag into this variable speed Sullair compressor, and kind of the optimal place for this guy, I have determined, is actually going to be right about in there. Adequate spacing away from the control power transformer and adequate spacing away from my phase protection relay. But what's going to happen is my phase relay is going to have to slide down. Actually, it's going to come off. I'm going to cut this DIN rail, and this relay is going to actually slide down to make room for this guy. I mean, I could put some DIN rail like maybe down here, but all of my connections are going to be here and over here, so it doesn't make sense to me to have it all the way down there. Also, just for initial status monitoring, troubleshooting type things, it's easier to have this thing right up here at about eye level. And so yeah, I'm going to do that. You can see I got my drive protected. Power is off to the unit. You can see power is off to the unit. I have no blinking lights on anything in here. So yeah, I got my drive protected. So first thing we're going to do is we're going to yank this, cut this DIN rail, remount, move this down, and then we'll fasten our DIN rail here for this guy. So see you in a few. All right, so now that our phase protection relay has been moved and our smart tag is mounted, I kind of wanted to run through real quick what all comes in the installation kit with these things. And just another quick note, anytime you make a change inside a compressor electrical cabinet, whether you're adding hardware or whatever, you always need to take into account the necessity of these items to be able to dissipate heat. And that's why you don't want to put two items that generate heat or that need to dissipate heat. You don't want to pack them right up next to each other. You want to leave some space in there so they can breathe. It's actually that's a UL standard. Anybody that's UL certified for panel building will tell you that there is actually standards and things that they have to follow when they build these panels to allow for heat dissipation. So just always remember that when you're adding something to a compressor electrical cabinet. Things got to breathe, so try and maintain a good amount of spacing around everything, particularly something we know like a control power transformer generates a ton of heat, so we want to try and give that guy room to breathe. So anyway, what all comes in this kit? So obviously you've got the smart tag. They give you a nice pre-cut piece of DIN rail that I've already mounted here, and then you get some end blocks, and you get fuse blocks for your line and neutral here that is going to be powering this tag. They didn't used to come with these. That's a relatively new thing, so that, very cool. Good job, Airmatics. So you get your baggie with all your different plugs for this thing, and we'll go over all that in detail here in a moment. The other thing you get, so we've got these fusible links right here. They all come pre-labeled L1, L2, L3. They do come with fuses already installed. That's going to be for the 480 volt input coming into the smart tag. So it can look at voltage. It's going to look at both voltage and amperage to give you a kW reading for this compressor. We have 3 temperature probes. So one is for ambient, one is for the compressor discharge, and one is going to be for the drive end of the motor. You want to get that as close to the bearing as possible. You do get some insulating tape to install these, and we will go over that later. We've got a Modbus communication cable. We have just some wire up all your power input, stuff like that. Red, blue, and green generally speaking, anything that's 120 volt, you're going to run in red. Anything that is 24 volt, you're going to run in blue. And then your ground is your ground. They do give you these little guys if you have the crimper for them, which I do, so we will be using those. You get a couple different size zip ties, you get some sticky backs, and depending on your setup, you will have either 3 or 4 of these CTs that are going to feed back to the smart tag. And those just clip around your wires there. Basically, you're going to have 3 of these are going to clip on your incoming to monitor machine amperage, and then one of these is going to go on one of your motor leads, so it can monitor VSD output as well. The other thing you get is they give you these self-tapping screws. They're a Torx head. I don't use them. I've got some regular 5/16 self-tappers that I like to use. So that is what all comes in the install kit. They got you pretty well taken care of. So next on the agenda here is going to be, I think what I'm going to do is I'm going to get everything wired up on this card that is for the card, that doesn't actually communicate or control anything with the machine. So we're going to be looking at our temperature sensors, which on this one, because we're using Modbus, I'm not going to need the air and discharge temperature sensor. So that's just going to be the motor bearing and the ambient. We'll get the CTs wired in, we'll get the 120 wired in, 480 wired in, we'll get all that wired in. At that point I'll stop. I'll make another video, we'll go through all that, show you where it connects, both here and at the compressor side. And then after that, I will finish with the serial communication between this and the controller. And then there's one, they use the remote unload to control the load unload on here. I think just because it's easier and more reliable than using the Modbus for it. I don't know that 100%, but I think that's the case, is that using that digital input for controlling load and unload is just a more reliable connection. So yeah, once I get all that, like I said, I'm going to get the smart tag specific stuff done, and then I'll check back in. We'll go through that, and then we'll get this talking to the controller. So see y'all in a few. Hey, just checking in real quick here, ladies and gentlemen. As I was installing these CTs, these just clip around the wires here to read your amperage. These are directional CTs. So when you install these, you want to make sure that they're installed so that current flows the direction of the arrow. Also, when you install them, make sure, like I've got mine sitting on the bottom of the cabinet down here, make sure you install them in such a way that they're not going to fall and get damaged or damage something else, or end up hanging by their wires or something like that. So just a couple of considerations. Like I said, just make sure you install them with the current flow in the direction of the arrow, and then make sure you install them in such a way that they aren't going to fall and get damaged or damage something else. So getting close here. We'll check back in a little bit. Welcome back, compressed air friends. So what we're looking at here is the drive-in motor bearing temp sensor that ties into the smart tag, and that's just basically taped on there with that high temp insulating tape that comes in your kit. It used to give you a real nice putty, but the tape works good. Usually I will try and come through nice and low and put the sensor nice and low. That way, it's never happened, but if the tape were to fail and that sensor falls off, it doesn't end up getting into the motor shaft or anything like that. So so that's that guy. And then come up here. So right here, so here's my Airlinks antenna, flex conduit coming in for the Ethernet cable, and then I've stubbed up my ambient temp sensor right there, right up through the roof of the machine. Then if we come inside the cabinet here, Sullair is nice to you. They give you these little extra knockouts that you can use. So that's where my temp sensors are going. I just pop the plugs out of there and put my connectors in there. So we are basically wired up except for the actual control interface with the machine. So this is where I wanted to kind of stop real quick and show you guys what's going on, what this looks like. So we have our CTs right here. Those are coming from CTs down here. And so we have a CT on each phase, and then one phase of the motor for the VSD feedback, so that the smart tag knows if the variable speed drive is actually running where it told it to run. And then we have our two temperature sensors. We have the motor drive-in we were just looking at, and the ambient temp here. Normally there would be a third one for air and discharge temp, but because we're going to be hooking into the controller via Modbus, we can actually get that information from the controller, so we don't need to run that third temperature sensor. So at this point, all we really got to do is right up here on this plug is our digital ins and outs, which we covered in detail in another video. I just basically got to run this to here for the remote unload signal, and then I need to plug in somewhere in here. Yeah, right here. No, down here. There we go. Yeah, down here, and run a Modbus wire over to there, and that'll be it. So once I do that, we shall check back in, and then at the very end I'll go through and actually tidy this up and make this all look nicer than it does right now. You can see all my zip ties are just kind of hanging loose until I get everything ran and put where I want it. So yeah, that's where we're at. Like I said, we just got a little bit of work to do here, plug in the Modbus cable, and we'll be rocking and rolling. So we shall check back when that's done. Well, there we have it, compressed air friends. This smart tag here is officially official. So really the only changes you'll notice from the last time you saw it is we now have our digital wires up here. We got our 24 volts in, and we got our signal out for the remote unload, and we now have our Modbus wires hooked up here. And shoot over here, the Modbus wires actually hook into what's called the BUI board, BUI, Basic User Interface, and the drawings that you will get from Energair will tell you that it goes on J2 RS485 plus and minus. It does not tell you which terminals those are. That information is going to be on the wiring diagram for this particular machine. So you just gotta hit the QR code and pull up the wiring diagram, and it will show you who's who there. Yeah, other than that, man, we're good to go. We're ready to rock. So when it comes to actually commissioning these, all of the newer Airmatics stuff, let's see if I can get a good shot of this in here. So you can see right there is a part number, right there is a serial number, and right there is a password. And if you pull up the manual on this guy, it will actually tell you how to plug in with an Ethernet cable, there's a certain protocol which you have to type in that part number and serial number, and it'll bring up the interface page for this. You type in the password, and then you can get in and start configuring things. I can do that. I have done it. I know how to do it, but it's a lot easier for me, and probably going to be a lot easier for you to snap a picture of that, snap a picture of the data tag on your air compressor, and then email that into support at Energy Air and say, hey, I've got power to my smart tag, which I don't have any power to this thing yet, but you say, hey, I got power to my smart tag. It's showing me on comm gateway, comm cloud, so it's talking to you guys. Go ahead and commission this thing for me, and usually they will get back to you within a couple hours, maybe half a day, and say, yep, you're ready to rock. The other information when emailing that in, if your customer has a designator, like this is compressor 1 or this is compressor 3 or whatever, make sure you let them know that, so that that information can get displayed in the cloud system. But that is that for now. Next time, so with this one, the next compressor does not have the STS controller. It's going to have the Supervisor Controller, which is the older Sullair controller. And this setup is going to largely be unchanged. Like, all this stuff down here is obviously going to remain the same. I believe we are still going to have the remote unload, and we are still going to connect to the controller via Modbus. However, the Modbus that the supervisor speaks doesn't quite jive with the smart tag, so we have to put in what's called a Mirius gateway, and it just basically acts as a translator between the two. So I'll show you guys that on the next video. For right now, I'm going to call this guy good, and haven't decided yet, because these wires are leaving. That's actually, that damage right there is from me, and I had to peel the tape back to see what size wire those are. Those are actually too small for this machine, so those are going bye-bye, and the breaker's too small. So I haven't decided yet if I'm going to run a suicide cord into here and just power up the control circuit, or if I'm just going to flip the breaker on and leave it until the electrician comes back and fixes his mistake. I haven't decided yet, but in any case, yeah, there you have it. So you'll notice when I was covering in the other video, these digital inputs and stuff here, we're not using any of that. The sensor inputs over here, we're not using any of those. That's all coming via Modbus here. So anything we would have normally brought in here or here is all coming right through here. So that's why the top of this thing looks so barren. So that's it for the STS. I would actually really love to dive a little deeper into the control wiring and stuff on this, but I don't want to step on Energy Air's toes. That's all kind of engineered from them. So all I can tell you on that is I've been doing these types of projects for many years, and I still buy the connectivity drawings every single time, because number one, it's just a good reminder for me of how to wire this stuff up. But number two, you can then print a set or email a set to your customer and say, retain these for your records, because we have made changes to the factory wiring. So yeah, I always get those. I would recommend that you do the same, and it shows you, again, if I felt comfortable doing it, I would. I don't want to step on Energy Air's toes, but it shows you pretty straightforward how to wire all this stuff up. And even on the ones that get a lot more complicated than this, some of your electro-pneumatically controlled machines that you can't Modbus into anything, so you've got all your digital inputs, you got a bunch of digital outputs, maybe you got to wire in and bypass the pressure switch or whatever else. Those drawings are invaluable for that. So, but anyway, enough of me droning on. That's what I got for you guys. See ya. All right, compressed air friends. So moving right along here. We are working inside of a Sullair variable speed dryer here, and we come to our control board here, and what we're doing is we are tying in the fault contacts so that if this dryer faults out for any reason, the other end of this wire here is connected to the Aero panel to a digital input there, which you'll see when we go to terminate in the Aero panel, so that if the dryer faults out, the Aero picks it up, registers it as a fault, and then we'll send out an email to the appropriate people saying, hey, dryer number 3 faulted out, you might want to go see what's going on. So tying into the digital inputs of an Aero are a little bit different. Normally a digital input is just, it's a loop. So you might have, say, 24 volts generated here, and whatever it is, your controller or whatever will send that 24 volts out. It will come through a set of contacts and then come back. And it's literally a loop. The Aero on its digital inputs is actually looking for a complete circuit. So it doesn't send a loop out, it just looks for power to come in. So what you have to do here is, just what I've done here is, I found the 24 volts here on the wiring diagram. This is actually going to power up the drain. These wires down here are going to power the drain. So I just I scavenged the circuit off of here. My neutral wire here that's going to the Aero is just tied directly in with their neutral wire. I took the hot here, the 24 volt hot, and I looped it down, brought it into the common on the alarm contacts, and then this wire is in the same cable with this other black wire over here, and those go right over to the Aero. So if this dryer were to fault out, you will get a full 24 volt hot and neutral feeding into the Aero, not your standard DI loop that we think of. Only other thing I want to mention on this, I'm actually tied into the normally closed alarm circuit, but it's open. And what I mean by that is right now, dryer is off. See, my drives are dead. Dryer is off. If I hit an ohm meter right now on these two terminals, I would get short circuit, right? No resistance, or very, very low resistance. But what happens is when the dryer kicks on, everything boots up, that contact changes state and opens up, and it will close again on fault. So even though it is technically the normally closed circuit, it operates like a normally open circuit, because when the controller boots up, it changes states. So that's always something to check for when you're tying into any kind of contacts like that. It is technically a normally closed contact, because when power is off and this thing is in what we refer to as the shelf state, or the state that it would be in sitting on a shelf, these contacts are closed. As soon as this powers up, they open. So always be mindful of that when tying into any kind of contacts, whether they be alarm contacts or whatever. Just give them a quick check before you assume you know how they work, because some companies would actually label that as a normally open, and it's a real quick, easy check just to make sure you know what you're dealing with. So that's it for the dryer. All right, friends, so we find ourselves now at the actual Aero panel. This can look a little bit intimidating at first, but once you dive into it, this is actually relatively simple. So inside the panel, we have the classic Metacenter controller. Gasp! Yes, this is classic Metacenter. The Aero is basically an overlay on it with some improvements to the control system and whatnot, but at its heart, she's still a classic Metacenter. We've got our DI-DO relay here that is connected to everything. That's more for the virtual relay automation, stuff like that, stuff we're not going to get into today. maybe one of these days I'll do a video where we do some virtual relay automation, or perhaps next time I'm at a customer where I have done it, I might walk you guys through it. But that's mainly what that guy's for. Then we have the unitag, which we have covered before, and then down here we have our terminal strip, which is where we are going to land everything. They have done you the favor of basically giving you a layout right here that tells you where everything's going to go. So for example, what am I looking for here? We want the system pressure right here, right there. So X11 system pressure 1, and that's going to be the plus. The minus is over here, so we're going to be on terminals 42 and 39 for our system pressure sensor. Dew point sensor, we're going to be 51 for the plus, 52 for the minus, and so on and so forth. So it goes on. Whatever you're hooking up, you basically just find it over here. And so for example, our dryer inputs are going to be up here. Anytime you see uni, that's short for the unitag. That's telling you that this terminal 25 here is wired to the unitag. Let me see if I can find, yeah, so then you'll have ones that are part of the actual Aero system, and you have ones that are the unitag. But for example, so our one of our dryers, say dryer number 1, is going to be, the fault's going to be on digital input 1. So our plus is going on 25, our minus is going on 26. It's literally that simple. So if you are lucky, when you come to wire this up, your installer, electrician, whoever, will have all your cables already pulled into the panel. They will all be labeled. I've already checked to make sure these are all labeled, everything's here, and you will have your Ethernet cable that goes over to your Fortress hub, which we'll cover the Fortress hub in another video. But one thing I want to show you guys, so the Ethernet connections are actually in the bottom. So technically what should happen is this Ethernet cable should get pulled back out, popped out of the box or whatever, and plugged in the bottom here. But if you follow this cable right here, it literally runs from here straight up and into there. So what I'll usually do is I'll just disconnect that guy right there, and I'll plug that guy in right there, and now I don't have to pull this back out or do anything. Now obviously I'm going to train that up, make it look nice, but I just wanted to show you guys, cable from here to here that's literally all that cable is. This one comes over here and does some funky stuff and then comes back out and all that. But as far as your connection to the Fortress hub, you can either pop your Ethernet cable back out and plug it in the bottom. You can actually, with a little bit of work, yeah, you don't want to come out today, but you can actually unplug this guy from here and then just get a an Ethernet union, and then this will just plug into one side, this will plug into the other. You can do it that way too, or you can do as I've done and just unplug it up there at the unitag and plug in your Ethernet cable. So I'll check back in here in a little bit. I think what I'm going to do is I'm going to get I'll get the sensors wired up quick and show that to you guys, and then I'll come back after that and wire all my dryer inputs in, and then I'll show that to you guys after that's done. But yeah, don't let this cabinet intimidate you. There is a lot going on down here, but as far as your interaction with this stuff, it's pretty limited. The door panel shows you exactly what you need to know, and yeah, it's really not too bad. So let me get cracking on this and I'll check back in. All right, friends, we are all termed up here. Like I said, we got the sensor wires, they were there before. now we have our digital input wires coming in here. Plus and minuses coming from the dryer contacts. Again, you're going to determine the wire color when you hook these up at the dryer. So again, I just know that black is my negative, red's my positive. That's just how I roll. So you'll determine that at the other end where it hooks up to the dryer. You just have to match it here. And yeah, all compressor information is going to come via the Ethernet cable here. So we have no wires coming into the Aero at all telling us anything about air compressor status. That's all going to come via the Ethernet cable here. As we showed in the Fortress Hub video, every air compressor has a Ethernet cable pulled to the Fortress Hub, and then from there we have one cable that comes out here to the Aero, and all that information gets passed right here. So it's actually a very easy, very slick setup. And yeah, that's it, man. I would call this a pretty basic installation. I mean, the only thing we really did kind of outside of the norm is we put the dryer fault contacts in here. If it wasn't for that, you would literally have, I mean, we put a dew point monitor in. Again, that's optional. Really at a base level, you just need the sensor for the air pressure sensor wire here, and then you need 120 coming in here to feed the thing, and you need an Ethernet cable. That's, I mean, it is very simple. So now that we're all hooked up, nothing to it now but to push our fuses in and start getting this bad boy commissioned. And again, once you are powered up and online, you will take a picture of the data tag there and send that to support, and they will start getting you set up on the cloud as well in the background. And that's it, man. That's all it takes. So I'm gonna grab my tablet, pull up the book on this guy, go through the commissioning parameters, which if you've ever commissioned a Meta Center, they're pretty much identical. And then we got a little bit of stuff to set up in the Aero touch panel, and that's it, man. This thing's done. So grab my tablet and we will go through all that. All right, y'all, so we are fired up and running here. Well, not really running, but we at least got power to the machine now. So I've got the book here, and we're just gonna do a quick run through basic setup of this guy right here. They give you all, well, and I'll show you here, they give you all the parameters that you really need to be worried about setting up for a basic system right here in the book, in its own little section, which is kind of nice. You can see I got some stuff scrolled on a piece of cardboard here. We'll go through that as well. But so first things first, when you fire this thing up, you should be getting a pressure reading. If you're not getting a pressure reading, check your sensor wiring. You got something going on there. You'll see from the earlier video, I kind of biffed the sensor wiring because I wasn't paying attention to the wiring diagram in here. So got that fixed though. So now we're reading. So what we're gonna do is we're gonna hit plus and minus together. Man, that's a horrible glare. We're gonna hit plus and minus together. We're gonna put in password 32. Hey, let me in. There we go. All right, so if our pressure reading here was not correct, it just tells you here you can go to menu S4 and adjust your offset and range of the pressure sensor so that it reads correctly. If you're using the one Energier gave you, you're probably going to be fine. So we're going to navigate to menu SO2 and set up our number of compressors. So SO2, hit enter, and this is where this thing comes default for PSI, CFM. So if you want to change that here, you can. Number of compressors in my system is going to be 3. Pressure max, they're all rated for 135. I usually like to go about 5 over. whatever the rating is. So we're not going to run anywhere near that though. So that is these two parameters here, and then if we scroll up to the top of this page, all right, so whoops, CF, which is control stop function, you either get a check mark or an X. If you set it to an X, what that means is when you command the central controller off, it is going to unload the compressors and hold them in standby until you command the central controller back on. If that is set to a check mark, then what it does is when you turn the central controller off, it just returns the compressors to local control and lets them run as they may. It's going to be up to you and your customer which function works better for you. So I generally like to have it set to X, and I will just say don't hit the stop button unless you mean it. But there may be some customers that are like, no, I want to be able to put them in local control. So these two settings here, tolerance and dampening, those are a little bit complex to dive into for the purpose of this video, but maybe at some point we'll dive into that. Basically, you're just setting your system reactivity there with tolerance and damping, either making the system more or less reactive. If I got to do any adjustments on that once I get the system up and running, I'll be sure to show you guys. But normally, you don't have to play with those too much. All right, so we're going to jump out of S2. We're going to go to S1. So we're going to hit clear, and we're going to scroll to S1, enter. All right, so setting your clock time, nothing too crazy here. It is in 24-hour format, and the date is what I would call the European style, where you have the day, then the month, then the year. Usually in America, we would go month, day, year. So just keep that in mind. That's day, month, year. Other than that, that's pretty straightforward. The other one it wants you to set is auto restart. Again, you get a check mark or an X, and this is basically if there's a power outage, once power comes back on, the system will automatically restart. The PS is pressure scheduling, which we won't go over right now, but it is enabled. And then rotation interval, RP, that's in here somewhere. Yeah, RP. If we were going to rotate on a schedule or something, I would be more worried about setting that up. But we're actually going to go for efficiency running, so that RP is not going to be as important. So let's go ahead and go to C3 asset configuration. So this is where we got to do a little bit of math. So compressors 1 and 2 in my system are going to be treated like no load machines. So when you go in here, it's just going to be an I-485. We got a 10-second ramp up time for starting and loading, and then this number here, I'll explain that in just a second. When we go to compressor 3, which is a variable speed drive, same thing, except we are a V485 now. 10-second ramp up for starting and loading. And then over here, so this is true of Classic Meta Center. This is true of it of the T1 that's in the Aero right now. This gets a lot of people screwed up. I've seen this set up wrongly a number of times. So what you got to do is you have to figure out what your largest compressor is. So in my case, it's C3. At full load, puts out 985 CFM. Okay, so C3 at its peak output is 100%, and then my lowest output, 235, when it's at minimum speed, is 23% of that. So my lowest output, 23%. Now, the 683 CFM that C1 and C2 are capable of putting out is 69% of my largest compressor. That's why that number on C1 and C2 is 69%. This number, anytime you have a variable speed, variable capacity, whatever, this is basically asking you at what percentage of full load does it become more efficient to switch to a non-variable machine. And so since my fixed speed machines are 69% of this, if you are running this variable speed drive at 69%, it's going to be more efficient to just fully load a fixed speed. So that's what all those numbers are. So your biggest compressor is going to be your 100%. Everything else is based off of this number. All right, so don't get that screwed up. My tablet timed out on me again. All right, so then asset running hours I'm not going to worry about right now. That's pretty self-explanatory. Just put your running hours in for each machine. So then if we go to table 1, which is going to be our default pressure table, and this is where we're going to set high and low pressure, and we're going to set our pressure minimum and all that stuff. So basically my high point's 120, my low point's 180. The Aero is going to try and maintain about the middle of that. My pressure minimum, which is kind of my oh crap pressure, is 95 psi. So if pressure gets down to 95 psi, it's just going to start calling for machines and trying to make air. It's not going to be too worried about efficiency at that point. This right here, you can set your sequence for schedule or for equal wear, or the percent sign here is for efficiency. I've usually found I get best performance out of these things if I set them for efficiency and I make all compressors the same priority. There are certain setups where sometimes prioritization makes sense or equal wear makes sense, but in this case we're just going for efficiency. So once you get to this point, you are pretty much set up for a basic system, and then we're going to do the basic setup in the Aero screen, and that'll be that. So, see ya. All right, friends, so here we come to the Aero touch panel configuration portion of this, and you can see on mine, I don't have any of the compressors tied into this just yet, but 113 psi system pressure, ambient temp 76.3, dew point 20.2 degrees, so we're looking pretty good. Actually, what I probably should do first and foremost is log out of that, and let's go back to the dashboard. So this is pretty much what you'll see anytime you walk up to this thing. V up here in the corner just means it's set to view, which means you can't really change anything without logging in. If any of my compressors were running, the status would be showing over here, whether they're loaded, unloaded, partially loaded, whatever. That's our on off down there for the system. And one of the things that's kind of neat about these Aeros is any of these you can just tap and it will show you a chart over time, and you can come in and adjust your windows and all that stuff. But it's just that easy. And then we can go back to overview, and if I want to know what my dew point has been, I tap and it'll go in, it'll show what my dew point has been. Obviously we don't have much data because it just got running, but I'll go back to overview. So the first thing we're going to have to do is we're going to have to log in, and we're going to have to log in as the admin. So we're going to tap up here on the V, and we're going to say sign in. And I don't mind sharing this with you guys because it's 100% necessary to the program here. And if you called Energair, they would probably give it to you with no questions asked. So our login is going to be root, all lowercase, password is CNC, and then we have to go boom, boom, we want underscore 1, 2, 3. Okay, so now it is showing R up here for root, and now we can start getting into some stuff here. So I like to think of this as a 3-step process. We're going to configure the system and sensors, we're going to configure the assets, then we're going to configure our alert points. So we're going to go right up here on our three bars, and we're going to go devices, and over here we got some icons. We can either view or edit. We're going to edit. And so the Aero, that's just there. You can't really do much with that. You're going to set your time zone, and you're going to set your commissioning date. That's under system properties. Next, we're going to go to system configuration. This is where you are going to choose what's shown on the screen, on that main screen. So like system pressure is enabled. You set your ranges in here as well. That's enabled, but I haven't set that yet. I haven't set the ranges yet. So our dew point sensor is enabled. That's our range. Just so you know, those dew point sensors, the range on those is -60 to +60 Celsius, which comes out to that right there. And then our temperature sensor is enabled, which I didn't have that wired in earlier, but that's not a big deal. So once we get all that set, we're gonna hit save right there. I'm not gonna hit save because it's all set already. Yeah, okay. Next thing we need to do is we're going to go group members. Okay, so this gets pretty vital right here. So you're basically just going to check the number of boxes for how many compressors you have, and you're going to go into I'll go into compressor 3 here because that's the most complicated one. That's the variable speed drive one. So you're going to give it an asset ID. That's what's going to be displayed on the screen. So you can't have any spaces, so I usually use an underscore. So this one I just said compressor underscore 3. If the customer had a different name that they knew it under, you could put it in there. Otherwise, compressor 1, 2, 3, whatever. That can be pretty much whatever you want. You have a drop-down menu here where you can change variable speed, load, unload, variable capacity, whatever. We're variable speed. Full load capacity. And so this is a little bit tricky. Full load power in watts, not kilowatts. So 186 kilowatt compressor is 186,000 watts. Got to watch that. And then down here under asset, right? Yeah, right here under asset. Crap, I wanted to have one of those handy. Hang on a minute. All right, so on your smart tag, right up here on top, I've showed you this before, you have the part number, serial number, password. Obviously these numbers aren't going to match what's in the screen because this is for compressor 1. What you have to do is you have to input that part number dash serial number. That way this thing knows which air tag to look at. If you don't do that, the system will actually, it's a little bit misleading because if you don't do that, the system still works, but you have a heck of a time when you are trying to upload changes or anything like that. So that's pretty much how that should look. All this information here is going to be available on your Cage Eye data sheet. for that particular compressor. Otherwise, you can get it from the manufacturer, from the OEM if you need it. So yeah, that's how that should look. Again, this is pretty vital. It will cause you headaches if you do that wrong. So we're going to hit save changes, and then once we have all of our compressors all set up in here, we're going to go up here and hit save. And then, very important, we have to push to device. Are you sure you want to push configuration to Aero? Yes. And then that changes to updated. And now if we go back to the dashboard, obviously mine's not going to change because it was already set up, but yours will now have all of your compressor numbers in here and all that fun stuff. So that's setting up your assets. Now if we come back in here, we go to devices, and again we go to edit. So then we're going to go to alert settings, and these are all different things that the screen itself will show that there's an issue going on. Like I got my system pressure. We go below 90 or above 145, this thing's going to throw an alarm. Dew point, we go above 40, it's going to throw an alarm. Ambient temperature below 40, above 120, it's going to say, hey, we got an issue. So you can, and the thing you got to remember is this is just in here. When you go to the cloud, which we'll do later on, when you go to the cloud and actually set your preferences for your account in the cloud, you can make these whatever you want. You can get alerted about whatever you want. And actually the list inside the list of things you can get alerted for per system, per asset in the cloud is pretty amazing. We'll go through all that. And then we need to set our pressure table, table 1. I set it to match exactly what I set in the T1 earlier. So 120, 108, 95 minimum. Sequencing is energy control, and they're all priority 1. So here, dashboard. Just one other thing I want to show you guys quick on this before we get done. You can swipe down from the top and it will bring this menu up. If you ever need to connect a laptop to this thing, right there's the IP address to do it. And then also, if you ever get into trouble and you need to restart the system, restart it right there. Go same as power cycling, basically. So just know that that's there. And that's that. So once I get some tags hooked up and all that, we'll revisit this thing. But that's pretty much setting up the Aero. Not a lot to it. Peace. All right, compressed air friends. So this smart tag for the Sullair Supervisor Controller is all wired in, and it's pretty much the same as any of the other ones, really. We've got our CTs here, 120 in, 480 coming in here. There's our 2 temperature probes for ambient motor, and then we have our digital controls up here. This is just basically to control the loading and unloading of the machine, and all other information is coming in via the serial comms. But we got to do it a little bit different with the supervisor. So we actually have to take our sequencing terminal, and we're going to run it into this Mirrorless gateway, and then it's going to run out of that Mirrorless gateway and come right into the Modbus port of the smart tag. And that is how we are establishing serial comms. There is some setup to do on these Mirrorless gateways. It's super easy. When you buy them, Energy Air will give you the documents and stuff and everything you need to be able to get the right database in there to get it to work. And yeah, super easy process. Instructions are straightforward, nothing to it. So I'm gonna get this guy rocking and rolling here. I gotta get power on and get the fellows over at Interger to get this thing commissioned for me. So there we go. I got one more of these to do. I'm not going to make a video on it because it's going to look identical to this. So once all the gateways once all the smart tags are commissioned and the Aero is working as it should, I'll do another quick video on that. And that'll be that. So, see ya. All right, friends. So today we're going to take a peek at this Fortress hub. All this really is a handy dandy spot to put all of your cellular gateway and your router and all that good stuff that you need for the remote monitoring capabilities of this Aero. And there's really nothing to it. All this up here comes pre-wired from the factory. All you got to do is have your electrician hook in the 120 right there, and then you'll wire in your 24 volt DC power to the gateway, and you got to mount the gateway to this little back plate and put it on the DIN rail and all that. Your electrician or whoever should have an Ethernet cable ran from each compressor, and then one more going over to the Aero panel itself. Does not matter what configuration the plug goes into the switch. Whatever suits you. You'll have your patch cable from the switch to the gateway, and that's it, man. It all comes in one nice little spot here. The only other thing, the standard antenna that this gateway comes with looks like a little hockey puck, and that is normally what you would see up here. That's the high gain option, only because this place out here that I'm working is kind of remote, so we opted for the high gain antenna right from the get-go. And I mean, like I said, it's pretty simple. All this is wired up from the factory. 120 there, DC there. You're going to connect your DC power plugs into there, obviously, and you're going to connect your patch cable and your antenna. That's really it. And then you're going to plug all this stuff in. Nothing to it though, so don't be scared of the gateway. This has gotten remarkably easier over the last few years. Just being able to pull these home runs back to here. It used to be that you could pull home runs back here to a switch, but then you still had the daisy chain serial network between the smart tags, and that is all by the wayside now. All you need is the Ethernet, which makes it a lot easier. So that's it, man. That's the Fortress hub right there. So, see ya.